Let's begin with namespace package. Traditionally in Python, a package required an dunderunit.py, but with PEP420 introduced in Python 3.3, we get namespace packages. They don't need an dunder init. So, what's special about namespace packages is that they allow you to split a single logical package across multiple directories. Now let's talk about executable directories. If a directory contains a file name dunder main.py, Python can run that directory as if it was a script. Python look inside the folder, finds dunder main.py and executes it. This technique is useful if you want to bundle your code in a folder that behaves like a runnable application. Executable zip files. Python also lets you run a .zip file as an application as long as the zip contains a dunder main.py file at the top level. Python will unzip it internally, look for dunder main.py and execute it. This is an amazing way to distribute Python applications. You can ship one single zip file. You can even create such zips automatically. Finally, let's cover executable packages. If a package has a dundermain.py file, you can run it with a dash m flag. Python will execute my package main file. This is very common for command line tools and frameworks. For examples, when you run. That covers namespace packages, executable directories, zip apps, and executable packages. Thanks for watching this video. We can also cover something called as uh, recommend package layout in this particular video as well. Recommended packaging layout. Please hold on, I'll just open that particular as well. So what basically sorry for that. Let me just quickly open that. Okay. Recommended package layout. Okay. So in this particular, when building Python projects using a standardized package layout, it is incredibly important. It improves the readability, helps new contributors on board faster, and ensures your code works well with Python tooling. A popular layout is the SRC layout, which separates the source code from the project root. Python project structure. Let's break down what a good Python project structure looks like. It first says this SRC asterisk. This holds the actual application or library code. Test all unit and integration test live here, ideally mirroring your source tree. For documentation, we have a docs. If you generate docs. For scripts, for any utility or helper scripts, for data example, for database migrations or one-off tasks. .github or CI stores CI/CD pipeline configuration. Key files include pyproject.toml or setup.py. Defines build metadata dependency. Readme.md gives new developers or users an overview of the project. License defines legal terms. Implementing plugins with namespace packages. Now let's look at namespace packages, one of the most powerful feature for creating pluggable architects. The namespace package lets multiple distributors share the same namespace. This means different packages can contribute modules to the same logical package without needing a central dunder init.py. Notice how each distribution has my app plugins. There's no dunder init.py in those my namespace or plugins. Implementing plugins with setup tools. Namespace packages solve the physical structure problem. Now let's see how to discover and load plugins dynamically. This is where setup tools entry points come in. You can declare any points in setup.py or project py project UML to tell Python here is plugin you should load under specific group. Here my app.plugin is the entry point group. Plugin dash e my is maps a name to a Python callable. To wrap it up, a good package layout sets the foundation for scalable Python projects. Using a clear project structure helps avoid import issues and improve team collaboration. Namespace packages allow multiple packages to contribute to a shared namespace. Setup tools entry points make your application pluggable, extensible, letting others hook in new functionality without touching your core code base. Hope this understands and clear the concepts. Thanks for watching this video.